in the spirit of programming a little more defensively, allow me to introduce another feature of Python as well, namely properties. So a property is really just an attribute that has even more defense mechanisms put into place, a little more functionality implemented by you to prevent programmers like me and you from messing things up like these attributes. So again, a property is going to be an attribute that you and I just have more control over. How? We just write a little more code using some Python conventions. And how we're going to do that is going to use in just a moment a keyword known as @property, which is technically a function. Property is a function in Python. But we're about to see some new syntax that allows you to decorate functions. And this, too, is a term of art. In the world of Python, you can have decorators, which are functions that modify the behavior of other functions, if you will. And we'll leave it at that without going too much into the weeds. And we'll see by example how you can use these decorators specifically to define properties. So let me go back to VS Code here. And let me propose that I do this. I'm going to go ahead and create, how about, a property called house as follows. Inside of my student class, I'm going to go ahead and below my init method and below my stir method, I'm going to go ahead and define a function called house that takes, as it always must, one argument at least. Called self. And what I'm going to do now is return and go to example how you can use these decorators specifically to define properties. So let me go back to VS Code here, and let me propose that I do this. I'm going to go ahead and create, how about, a property called house as follows. Inside of my student class, I'm going to go ahead and below my init method and below my stir method, I'm going to go ahead and define a function called house that takes, as it always must, one argument at least called self. And what I'm going to do now is return self.house. So I'm just going to define a method called house whose sole purpose in life is to return the value of house. But I'm going to define one other method, curiously also called house, but that's going to take into as arguments two values, self, as always, and also a value called house. And I'm going to now do this. I'm going to say I'm going to do self.house equals house. Now, what have I done? Well, let me just temporarily add some comments here. In a moment, we're going to start referring to this generally as a getter. And down here, I'm going to refer to this as a setter. And this is terminology you frequently see in the world of Java, if some of you have programmed in Java before. But as the names imply, a getter is a function for a class that gets some attribute. A setter is a function in some class that sets some value. And now, even though we're not done, and there's a bit of a mistake in the code I've already written, intuitively, what we're going to do is this. We're trying to prevent programmers, myself included, from circumventing my error checking that I put into place for name and house. How can I do that? Well, we don't have that many building blocks in programming. We have things like variables for data, and we have functions for actions. Well, why don't we do this? Why don't we somehow require that in order to access an attribute, you go through some function? And let's require that in order to set some attribute, you go through some function. And conventionally, those functions are called a getter function and a setter function. And why are we using functions, or in this case methods, inside of a class? Well, once you have functions, those are just actions or verbs that you and I can create ourselves. We can put any error correction I want in these functions because it's code that's going to get executed top to bottom. So how can I now prevent the user from setting the house to an invalid value? Let me borrow some logic from before. Rather than blindly do this, just set self.house equal to the house value that's passed in, let's add our error checking there. So if house is not in the following list of Gryffindor or Hufflepuff or Slytherin or Ravenclaw or Slytherin, just as before, let's go ahead and raise a value error just to signify that something has gone wrong. I'll be more explicit. I'll include a message like invalid house, quote unquote. Otherwise, I'm going to proceed on now line 21 to set self.house to house. So I've just copied, if you will, or retyped my error checking inside of this so-called setter function. Now, why have I done that? Well, to be clear, whenever the user or the programmer writes code like this, student.house equals, what's about to happen magically is Python will not just let the programmer access student.house directly, that attribute, that instance variable, aka self.house. It's instead going to magically, automatically call this setter function for me. How does Python know to do that? Well, if it sees that on the left-hand side there is self.house, where house is the name of the getter or setter, and then it sees an equal sign indicating assignment, that's just enough of a visual clue to say, wait a minute, I'm not going to let you access that attribute directly. I'm going to use the setter instead. Why? Because the equal sign means I'm trying to set, I'm trying to assign a value from right to left into that attribute. So what Python's going to do automatically is call this function for me. And that's amazing, because now I can execute code, an algorithm, to check, do I want to let the user, the programmer, set that attribute to that value? If not, I'm going to raise a value error, and you're just not going to be able to do it. If so, fine, I'll go ahead and set it for you. But in order to do this, we need a little more syntax. And I'm going to get rid of my comment, and I'm going to use that decorator. I need to tell Python to treat this method as a getter. And then the syntax for the setter is a little different. You now say house.setter. I wish one was getter and the other was setter. That's not the way they designed it. When you want to define a getter, you just say @property above the function. And you name the function exactly like you would like the property to be called, quote unquote house. Once you do that, you can now use a new decorator that's sort of automatically created for you called @house, because I called it house. And then you literally say @house.setter. And this whole line on line 17 is a clue to Python that here comes a function whose name is identical, but notice that it takes two arguments, both self, so you have access to the contents of the object, and house, which is just going to be a stir that comes from the programmer, from like the human input return value, so that you can set that value as well. But there's one fix I need to make now here. Everything else I think is still good. However, watch this. I no longer need this error check here. Why? Because if I scroll back down to my code here, I claimed a moment ago that code like this with student.house equals is going to automatically get Python to call my setter for me. Guess what? Even up here in my init method, calling self.house equals is also going to call my setter method, which is amazing because now I can keep all of my error checking in one place in the setter. And it will now get called either when I create the object for the first time because of init, or even if the programmer tries to circumvent that init method and change the value of this attribute, my setter will also get called. My setter will get called anytime I access .house. But there's one fix I need to make. Unfortunately, I have collided names. Right now, if we go up here on line 5, this is an instance variable. It's a string inside of myself, inside of the current student object called name. And this is another instance variable called house. Unfortunately, if I have an instance variable called name and house, I cannot also have functions called house. They're going to collide. You got to decide. Do you want the variable to be called house, or do you want the function to be called house? Unfortunately, you can't have both, because now Python's going to confuse one for the other. So the conventional fix for this is to do this, to have the setter not store the value that's passed in self.house, but to use an almost identical name, but to use a little indicator that means you know you're doing this correctly. You typically, by convention, put an underscore in front of the instance variable's name. And when you return it up here, you similarly put an underscore. So now technically, my instance variable is called underscore house, but my property, which is a fancier attribute, if you will, is called house alone. Huge amount of syntax, I know, but it's a very powerful feature. And again, this is why you can graduate from dictionaries alone and have so much more functionality at your disposal. Let me go ahead and clear my terminal window and run python of student.py, enter. Name, all right, let's go ahead and type in Harry. Let's go ahead and type in Gryffindor, crossing my fingers as always. And now look, invalid house. This is a good thing. Why? Because notice, in my main function, I'm still trying, maliciously if you will, to change Harry's house to not be one of the 4 valid ones. I'm trying to change it to his childhood home of number 4 Privet Drive. But because Python knows that, wait a minute, you're trying to assign, that is, set a value, and that value, aka house, is now defined as a property, you're going to have to go through the setter function instead to even let you change that value. And because I have this raise value error, if the house is not as intended, you're not going to be allowed to change it to an invalid value. So I'm protecting the data on the way in through the init method, and I'm even defending the data if you try to override it there. So I think the only solution for me, the programmer, is don't try to break my own code. Let me remove that line because it's just not going to work. Let me run python of student.py, and again, type in Harry, type in Gryffindor, enter, and Harry is indeed from Gryffindor. If I did something incorrect, like Harry from number 4 Privet Drive, enter, we're again going to see the value error because my code just doesn't let that value in via manual input now or via code just drive, enter, we're again going to see the value error because my code just doesn't let that value in via manual input now or via that adversarial change. All right, that was a lot, but any question on properties?
While we are using getters and setters, it's just for the purpose so that we can find that function, that method, that function in our code.
The reason that I'm going through the trouble of defining this getter or setter is because I want to make sure that programmers cannot do things like this. If I'm going through the trouble of validating the attributes for these student objects, I don't want you to be able to go in there and just change them at will. I want to have some control over that object so that you can just trust that it's going to be correct as designed. So using a getter and setter really just enables Python to automatically detect when you're trying to manually set a value. The equal sign and the dot, as I've highlighted here, is enough of a clue to Python to realize, wait a minute, you're trying to set a value. Let me see if this class has a setter defined, and if so, I'm going to call that, and I'm not just going to blindly assign the value from right to left. So it's just giving me more control. Other questions on properties?
When we use getters, we just have just one argument. And if we use setters, it's always going to be 2 arguments. Is that normal?
Correct. It's always going to be 1 argument, self, for the getter, 2 arguments for the setter, self and something else. And the intuition for that is if you're getting a value, you don't need to pass anything else in because you already know the object. It's called student in this case. So you're just going to get the value of that property. But if you want to set the property to something else, you got to pass in that argument. You've got to pass in the value to which you want to set it. So it's always 0 or 1. However, you see it as 1 or 2 because, again, any function inside of a class, aka a method, is going to be automatically passed self so that you have access to that current object in memory. How about one other question on properties?
Why didn't we use the same underscore house in init method?
A good question. So even though I'm using the underscore house here in my setter and the underscore house here in my getter, I deliberately did not use it up here. The reason for that is that by using self.house and this equal sign, that's the same pattern that I want Python to recognize. I want Python to automatically call the setter even when I'm passing in the house via the init method. If I were to change this to do this, that would circumvent the setter, and now there's no error checking in init whatsoever. So it's such a fine line. The only thing standing between us and error checking or no error checking is the presence or absence of this underscore. But that's typically the convention. By not using the underscore there, make sure that even that assignment goes through the setter so that honestly, I don't have to copy paste the same error checking in two places. I can put it just in the setter. So it's better design, and that's why I manually retyped it at first, but then I deleted it from init. Well, allow me to propose that we make one other change to this file. Might as well go ahead and define a property for name as well. And let me go ahead and do this. Maybe above the house property, just to keep things in the same order as I defined them earlier. Let me give myself another property. This one's going to be called name. It's going to take one argument called self as always. And this one, very similarly, is just going to return self._name. So I'm going to anticipate that I'm going to have to rename name also so that I don't have that same collision as before. But now let me go ahead and define another setter, this one for name. So the convention is @name.setter. Why name? Because the property I just created is called name. So the getter and setter sort of work in conjunction in this way, if you will. Let me go down under @nameSetter and define another function also called name. But the key thing here is that it's not identical. It's not the exact same function name and the exact same number of arguments. The setter, again, takes a second argument. And I can call it anything I want, but I'm going to call it name because that's what's being passed in. And I'm going to put my error checking here. If not name, just like we used to do, let's go ahead and raise a value error. And let's put an explanatory message like missing name, quote unquote. Otherwise, let's go ahead and update self._name to equal name. And I don't have to change init except to get rid of this duplicate error checking now. Because again, if I use self.name equals here and self.house equals here with no underscore, both of those assignments are going to go through my two setter functions now. Before we run this, let me go ahead and remove this adversarial code, which we know won't work because we're catching it. Let me go back down to my terminal window and run Python of student.py, enter. Let's type in Harry, let's type in Gryffindor, and that seems to work. Let's try, though, again to run Python of student.py with Harry from number 4 privet drive. This will not work. A value error with invalid house because that's not one of the 4 Hogwarts houses. And now, for good measure, let's run it one more time. And let's not even give it a name. Let's just hit enter when prompted. I can type anything for the house. I'll go ahead and still give it Gryffindor, enter. Now we get another value error, but this one is for missing name. So we seem now to have all the more of a defense mechanism in place to ensure that name is as we expect. It's got to have some value that's not blank. And house is as we expect. It's got to have one of those 4 values. But at the risk of bursting everyone's bubble and making you wonder, why did we just go through all of that? Unfortunately, Python really focuses on conventions, not hard constraints. And by that I mean this. If I go back into my main function after I've gotten a student on line 30, and I try to adversarially do something like this, student.house equals quote unquote number 4 privet drive, we know this won't work because my setter for house is going to catch this. Watch again. Python of student.py. Let's type in Harry. Let's type in Gryffindor, which will at least pass our check that's induced by init. But line 31 is going to trigger the same setter to be called, and we're going to raise a value error saying invalid house. Unfortunately, and if some of you are already thinking a little adversarially, tragically, look what you can do. You can change .house to be ._house. Why? Well, the instance variable is now called _house. The property is called house, no underscore. But the underlying attribute implemented as an instance variable is still called _house. And tragically, Python of student.py, let's type in Harry. Let's type in Gryffindor, which is correct. But watch what happens now. Oh my God, we slip through. So what was the point of all of this emphasis from me on doing things the right way, the Pythonic way, by having this getter and setter? Well, unlike languages like Java that just prevent you from doing things like this, Python itself allows you to specify that certain instance variables can be public and accessible to anyone's code, or protected, or private, which means that no one else should be able to change these values. In the world of Python, it's just the honor system. It's not baked into the language itself that there's a notion of visibility, public or private, or even somewhere in between protected. Instead, you're on the honor system. And the convention generally is, if an instance variable starts with an underscore, please don't touch it. Like, just don't. Like, that's on you if you touch that variable and break things. The underscore is meant to signify a convention that this is meant to be private, but it really just means please don't touch this. Sometimes if there's two underscores, which you can use too, that's an even greater effort by programmers to say, really don't touch this. But technically speaking, there's nothing stopping you or me from circumventing all of these mechanisms, these properties, these getters and setters. We're ultimately just on the honor system not to do so when we see instance variables prefixed with one or perhaps even two underscores. All right, so this is a lot all at once, this introduction to object-oriented programming, but it might come as quite a surprise that even though we might have identified OOP by name in weeks past, we've all been using classes and objects for weeks now in this class. In fact, if you think back on one of the very first things we did in this class, we used integers and just got integers from the user. But if you haven't already, if you go and dig into the documentation for integers, which again lives at this URL here, you would actually find that int itself is and has been for weeks a class. And in fact, this is the signature of the constructor call for an int, whereby you pass in x, like a number, quote unquote 50, or quote unquote something else. You pass in optionally the base, 10 for decimal, 2 for binary, or anything else. And that int function will actually return to you all this time an object of type int. That is to say, int is a class. It is a template, a blueprint for creating integers in memory. And anytime you and I have converted a string, for instance, to an int, you and I have been creating an object of type int that was calling apparently the underscore underscore init underscore underscore method that someone else, the authors of Python, wrote to give us back that proper integer. Besides that, if you can believe it, strs, strings in Python, have been classes since the first week of this class as well. If you look up the documentation for a str, which lives at a similar URL there, you will find that when you instantiate, that is, create a str, it takes optionally a parameter called object here, the default value of which is just quote unquote, which allows you to create, in effect, an empty string, a blank string, if you will. But anytime you and I have created strs or even used explicitly this str function, you are getting back an object of type str. Anytime you and I have forced a string to lowercase, per the documentation using syntax like this, you and I have been taking an object of type stir and forcing it all to lowercase by calling a method called lower, a method that the authors of Python built into the stir class, but it's been there from the get-go. So this notion of methods is not even new today. You and I have been doing it for this long. If you've ever called strip to remove the leading and the trailing white space from a string in Python, you are calling another method that came with Python, written by the authors of Python. And even though we didn't call it a class at the time, a stir all this time has been a class. And instances of strings are themselves objects, and those objects come therefore with these functions built in, aka methods, that allow us to do things like force to lowercase and strip white space from the beginning and end. Let's do another. List. Anytime you've created a list, either syntactically with square brackets or literally with list, open parenthesis, close parenthesis, which is also possible, you have been using a class. If you go to the documentation for list at this similar URL here, or more specifically, the tutorial on lists here in Python, you will see that a list is and has been, since the early weeks of this class, a class itself. And that list class takes as part of its initialization an optional iterable, something that can be iterated over, like 1, 2, 3, or some list of values, and you can then get back a list containing those same iterable values. If you've ever appended something to a list in this class, as I have myself in the past, you've been using a method called append that comes with the list class that, per the X here, takes an argument that allows you to append something to the current list, aka self, in the context of that method. We can do this all day long. If you've used a dictionary or a dict in Python, I've actually all this time been calling them dict objects, and that's for a reason. Dict itself is a class in Python. If you pull up its official documentation here, and you'll see that it is defined indeed as itself a class, and that class comes with methods as well. And so anytime we've manipulated dictionaries, we've been underneath the hood using all of those same methods. And in fact, we can see this if we're really curious. Let me go back over here to VS Code, and let me go ahead and create a new file that very simply does something like play around with data types. And let me go ahead and create a new file, for instance, called, say, type.py, just so that I can poke around inside of some values. And in type.py, I'm just going to go ahead and do this. I'm going to print out whatever the type is of, say, the number 50. And this is a function you've not necessarily seen me use already, and it's not one you would frequently use in your own code. There are other ways to detect, if you need to, what the type is of a variable. But in this case, type of 50 is just going to tell me and then print out what the data type is of that value. Now, hopefully, all of us could guess that 50 is indeed going to be an integer, that is an int, but we can see it in this way. And this, too, is what's powerful about knowing a bit of programming. If you want to know the answer to a question, just try it out, like I am here. So let me go ahead and run Python of type.py, enter, and there it is. When you print out the type of the number 50, you'll see on the screen in this cryptic syntax, class quote-unquote int. This is not something that you'd probably want to show to the user, but if you yourself just want to poke around and see what's going on, or maybe use that information somehow, it's certainly at your disposal to use with this type function for that. Let's change it around a little bit. Instead of passing as the argument to type 50 as an int, let's type something also familiar, like hello, world in double or single quotes. Let me go back to my terminal window, clear the screen, and run Python of type.py again. And now, voila, there it is. All this time, a stir is also a class. We can do this a few more times. For instance, let's go ahead and change hello world to just an empty list. Open square bracket, close square bracket. And this is starting to look a little cryptic, but again, notice what I'm doing. In square brackets is an empty list. We've done that before. That is the sole argument to this new type function, and that's just being passed to the print function so that the return value of type is the argument to print. So if I now run this code, Python of type.py, there it is. A list is a class too. You might recall that I said that you can also create an empty list by literally doing list, open parenthesis, close parenthesis. This is a bit of an inconsistency, as we can now identify that int and stir and now list, they're technically all lowercase. And I went to great lengths of creating my student class to have that capital S. That's a convention. Because int and stir and list and others come with Python, they decided to make their built-in data types, even though their classes all lowercase. But the convention, the recommendation in the Python community when creating your classes is indeed to capitalize the first letter as I did in something like student, capital S. But list, open parenthesis, close parenthesis, is identical to really just two empty square brackets. If I clear my screen and run type.py again, you see the exact same thing. The class is called list. Let's do one more. Let me change list to be not square brackets, but curly braces. We've done this before. Anytime I've done two curly braces with nothing in between, this, of course, is an empty dictionary or a dict object in Python. Well, we can see that now. Let me clear my screen, run python of type.py, enter, and there it is, class dict. It's been there this whole time. We just didn't call it a class until today. I can similarly do this one explicitly. Instead of two curly braces, let's write out dict with two parentheses. Now we have a lot of parentheses again, like with list, but this is just making even more clear that the type of a dict object is indeed the class dict itself. So this is to say that as new as a lot of today's idea and syntax might be, you've actually been using it, perhaps unbeknownst to you, for weeks now. We now just have terminology to describe what it is we've been doing all this time. And you now have the expressiveness with some practice to create your own classes, inside of which are your own instance variables, perhaps wrapped with those properties and your own instance methods. But it turns out there's other